Welcome to Chillin' 101. We hope this video helps.
You already know decimals and fractions. Now apply that knowledge. First, test a number. Try converting it to a fraction. If you cannot express it as a ratio of integers, suspect irrationality. Once done, examine its decimal form. If digits neither terminate nor repeat, it is irrational. Make sure to compare with known examples like square root 2 or pi to build intuition. Start with simple square roots. If the radicand isn't a perfect square, treat the root as potentially irrational and continue with verification steps. You will now perform the proof steps. Begin by assuming the opposite. Suppose the number equals a /b in lowest terms. Next, manipulate algebraically to reach a contradiction. Often parity or prime factor arguments reveal impossible equalities, as in the classic square root 2 proof. Once you derive that both numerator and denominator share a factor, the assumption fails, proving irrationality. If decimals are available, demonstrate non-repeating, non-terminating behavior, or invoke known theorems for roots and transcendental numbers to finish rigorously. You are finishing by assembling the result clearly. State the conclusion. The number is irrational because the contradiction holds or because its decimal fails rational criteria. Once done, restate the key inferential step so your reasoning is transparent. If calculations go wrong, check common errors, reducing fractions incorrectly, misapplying parity, or overlooking perfect squares. As a troubleshooting tip, re-evaluate the lowest terms assumption and redo algebra slowly. Often a small simplification mistake causes apparent contradictions where none exist.
Thanks for watching. Consider subscribing if we helped you.